Today we're going to be talking about solving exponential equations and inequalities. Now we're going to be doing this throughout the chapter. This is just the first look at this, and this day you want to try and get your bases to be equal, because if your bases are equal, then you can set the exponents equal. Okay, so if 3 to the x equals 3 to the 5th, then x equals 5. Your exponents are equal. And you always want to try and get to the smaller of the bases, meaning you want to break this 9 down into base 3. So I have 3 to the x, break the 9 down into 3 squared. So 3 squared to the 4th power, you multiply those exponents because I have a power to a power, so that's 8. So therefore, x is going to equal 8. Yes, they're going to get more complicated. Like this example here. Okay, so again, solving the equation. Break down so that they're in the same base. 4 can be broken down into base 2. So I have 2 squared. So I have 2 to the 5x equals 2. Now I can multiply again these powers since I have a power to a power. So that becomes 4x minus 2. Set your powers equal. I'm going to subtract the 4x over to get x equal to negative 2. And again, remember, you can always plug in these powers and make sure you get the same thing on both sides of the equal sign. You can plug in your answer to check your answer. Okay, now an application of this. In 2000, the population of Phoenix was 1,321,045. By 2007, it was estimated to be 1,512,986. Write an exponential function that can be used to model the population of Phoenix. Write x in terms of the numbers since 2000. So remember, an exponential function is something like that. Okay? Since x is the number of years since 2000, that's going to be our initial amount. This kind of looks like that initial amount, just we don't know whether b is growth or decay. It's not telling me. We can tell it's getting bigger, but they don't tell me by what rate. So our population in 2000, I should say that this number here, this 1.3 million, that's our a. So I have y equals 1321045. B times b to the x. Now they tell me in 2007, so when x equals 7, y is going to equal that. So I have So we have that equation. We have when y is equal to our 1.5 approximately million equals our initial amount times b, x equals 7. So we need to solve this equation now. It's a lot easier to solve. So I'm going to divide both sides by 1321045. And again, I don't expect you guys to be able to do this without a calculator. I pulled out my calculator when I was doing this earlier. So we get, rounding to 3 decimal places, 1.145 equals b to the 7th. Now this is when I'm using the stuff from the last chapter. I take both sides to the 1/7 power, or I take the 7th root. So therefore, we get b to be 1.02. So I need to write an exponential function. Our exponential function y equals I plugged in my a, which was 1321045. I plugged in what we found for b, and then we found x. Okay, b, predict the population of Phoenix in 2013. So remember, x equals 0. X is standing for the number of years since 2000. 2013, x equals 13. So what we're going to do is we're going to plug into our equation we're going to plug in 13 for x. And again, this is all calculator work. Putting that in your calculator, I got 1,708,912 people. Okay? So that's all, again, calculator work. Compound interest. This is probably one of the most useful things. You're going to be using this in your life when you're talking about your mortgage, okay? Or when you're talking about your student loans growing or things like that, okay? Compound interest is given by this formula. And it's very similar to the formulas that we've been talking about. The amount we have is equal to the principal, what I put in, initial amount. Since compound interest grows, we have 1 plus, so it's our exponential rate problem from the first section, 1 plus the rate that we have divided by the number of times it compounds per year. Meaning if it compounds monthly, compounds quarterly, you split that rate, you divide that rate up into the amount of times per year it's compounded, okay? And then that is to the nt power. The number of years times the amount of times a year compounds. Okay, so an investment account pays 5.4 annual interest compounded quarterly. That's going to be key. Even though it's not a number, that's key to us. If 4,000 is placed in this account, find the balance after 8 years. So let's find. We're looking for A. That's the amount after a certain amount of years. Our principal, what I put into it, 4,000. The rate, 5.4. Make sure you write that as a decimal. The number of times a year it's compounded, and t years. It says what's the balance after 8 years. N is the number of times a year n is, the number of times a year it compounds. Compounding quarterly. There's 4 quarters in a year, so it compounds 4 times a year. So plugging into our formula. Okay, so our principal, 4,000. 1 plus our rate is 0.054 divided by n, the number of times a year it compounds, to the n, which is 4, times by t. Okay, now again, this is calculator work. I'm going to show you guys, I'm going to pull up in my calculator how you're going to solve this. Okay, do the piece in the parentheses first. So do 1 plus 0.054 divided by 4. Now your calculator is going to do this order of operations for you. It's going to do the 0.054 divided by 4 and add 1 to it. Press enter. Now we want to take that to the 8 times 4 power. Okay, and then we're going to multiply that by 4,000. So we get $6,143.56. So we get $6,143.56. Okay, solving exponential inequalities. Okay, so solving exponential inequalities. What you have to do is, again, make sure that you have the same base. Once you have the same base, you can just take and say that x is greater than y if your sign is greater than, or x is less than y if your sign is less than. And again, this holds true for less than or equal to and greater than or equal to. So let me write these two things in the same base. We have 5 to the 3 minus 2x, write 625 in base 5. Since that's a fraction, I'm going to have a negative exponent. 5 to the 4th is 625. So now since they are the same base, I can take and say that 3 minus 2x is greater than a negative 4. And therefore 7 is greater than 2x, or 7 halves is greater than x. X is less than 7 halves. Now do a test. Test a point. Test a point that's less than 7 halves. 1 is less than 7 halves. So when I plug that in, when I plug 1 into this inequality, make sure you have a true inequality. So 5 to the 3 minus 2. So 5, is that going to be greater than 1 over 625? Well, I know this is a really small number. 1 over 625 is a really small number. 5 is a really big number. So that's true. I was just checking to make sure my answer was right. So our answer is x is less than 7 halves. Okay, there are your 3 lesson questions. Please make sure those are submitted on time.